You are welcome to my class today. My name is Dr. Kingsley. Okay, we want to dive into very important aspect of science today. Okay, and that is thermodynamics. So we have today thermodynamics. Okay, why is it very important? Thermodynamics is very important because of its applications. But before we go into that, what is thermodynamics? Thermodynamics is a branch of science that studies the energy changes that occur in chemical and physical changes. It studies what? Energy, that is heat, work, okay, and other forms of energy, and relate it to how they affect matter. Let me say, for example, ice can melt, okay, to water. Before ice can melt to water, there must be application of what? Energy for that to happen. Another one, if you add cold water to calcium carbide, there is liberation of heat. Now, all this heat that is liberated during chemical reaction, is there a way that we can make use of them? Yes. Their knowledge of thermodynamics is very important because number one, it helps you to know whether a reaction can go on by absorbing heat or by, okay, whether it liberates heat to the surrounding. Now, if you are holding a piece of chalk, that is calcium carbonate, you might hold it and you are looking for carbon dioxide in a place where you have this and they don't have carbon dioxide. You might be holding this, but if you know that when you supply what? Heat to this chalk that you are holding, that you can actually get what? Carbon dioxide. If you don't know, you'll be looking for carbon dioxide without knowing that what? The application of heat can actually give you what you are looking for. Now, heat can also speed up the rate of chemical reactions. So that is why it is very important for us to study this topic. Now, what are the terms that we use in thermodynamics? Because it's a new area that I'm introducing you into, I have to, okay, introduce some certain important terms to help you understand this topic as I go on, okay, into it. Now, one of the things you should know is system. That is one terminology used in thermodynamics. System. What is a system? A system is that part of the physical universe that the characteristics or properties are being under study. Is a part of what? The physical universe in which the properties are under study. Let me say you are in a lab and you are holding, okay, a test tube that you have mixed acid and base inside for them to react. That acid and base that is reacting is actually the what? The system. So the system is that what? Part of the universe that we are investigating. We are investigating the reaction between acid and base, and therefore acid and base becomes the system. Then another one that we have here is a surrounding. Surrounding, you need to know what surrounding is. Surrounding is anything outside the system. You are doing what? You are doing a practical concerning acid and base, which is the system. You yourself, the classroom, and every other thing within the immediate environment of that what? Lab constitutes the what? The surrounding. Every other thing outside the system in that lab, okay, whether the chairs, okay, you yourself, okay, all the other apparatus in the lab, all of them constitute the what? The surrounding. Now, we must know that what? System, okay, plus surrounding, surrounding, okay, is equals to universe. Universe. System plus surrounding is equals to universe. The number third term we need to know is the, okay, boundary. The boundary. Boundary, we can call it wall. Either you call it boundary or wall. Now the boundary is that which separates the system from the surrounding. Boundary separates system from the surrounding. I told you the acid and base in your test tube constitute the what? The system. You and the immediate environment constitute the what? Surrounding. The test tube itself is like a wall that separates what? You and every other immediate environment called the surrounding with the what? With the system. So that is a surrounding. Now we go to types of a boundary. What are the types of boundary or wall? We have different types of boundary or wall. The first one is what? Is rigid. I have I here, rigid wall. What is a rigid wall? A rigid wall is that wall that is what? That is not flexible. It is rigid, it is hard, it does not allow change in volume. Any wall or boundary that will not allow change in volume, okay, is called what? A rigid wall. Let me say, for example, if you have a gas cylinder that is made of what? A gas cylinder, okay, that is made of iron steel, okay, that is made of steel, okay, steel, iron cylinder, steel, okay, that is well covered, steel, is made of steel. We know that what? Steel have what? A rigid shape, okay. No matter the activities of the gas, okay, inside this steel, the steel will not increase in volume, it will not expand. Those kind of wall that does not change in volume, no matter what is happening within the system, is what we call the rigid wall. Then the next one is what we call flexible wall. What is flexible wall? Flexible wall is that wall, okay, that allow change in volume. Let me say, for example, you have a cylinder with what? A piston. Cylinder with a piston, okay. If you compress here, the lid comes down. If there is a gas inside, when the gas expands, the lid can be forced to move upwards, okay. This is where it is before, but due to the expansion of this gas, maybe if I increase the temperature, now the lid can actually go upwards. So due to expansion, this container piston, this cylinder has actually allow what? Increase in what? Increase in volume from here to here. That kind of wall is what we call the what? The flexible wall. Then another type of wall that we have, okay, is all right. We have number 3, 1, 2, 3. We have permeable wall. What is a permeable wall? A permeable wall is a wall that will allow the exchange of matter and heat. It allows the exchange of matter and heat. Let me say, for example, you have a cup, okay. This cup is a steel cup, but it is open. Assuming it's containing hot water, you see that after a while, 5, 10 minutes, 15 minutes, the hot water will be getting cooler. Why is it cooling? Because it is what? It is okay, allowing energy to what? To pass. Then some of the hot water can go as what? As a vapor. This vapor of water is actually matter. That is water on itself. So we can see that what? A permeable wall allows the exchange of both what? Heat. It allows heat. Okay, exchange of heat. It also allows exchange of matter, which is water in form of vapor in this case. So the next we consider is We consider diathermal wall. Number 4, diathermal wall. Diathermal wall is impermeable. It is impermeable. It is impermeable. Now, this wall will not allow matter, okay, to pass through, but it allows energy. There is loss of matter, but there is no loss of energy. Now, let me say that steel cup that we have, assuming it have what? A cover, is covered up. Are you getting me now? You see that what? Energy can escape because the water can get what? Cooled. Okay? It allows energy, okay, to be exchanged. But the hot water inside will not escape because when the vapor comes here, it will be trapped by the cover of the cup. So it allows energy because it will cool after some time. But there is no molecule of water that is lost. So that is what we call diathermal wall. Then we go to what? We go to adiabatic wall. Number 5 is a adiabatic wall. What is adiabatic wall? Adiabatic wall is a wall that will not allow either energy or matter to pass. It does not lose energy. It does not lose what? Matter. The example is a ideal thermos flask. Okay, ideal thermos flask, okay, is actually what? Is actually an adiabatic wall. It will not lose energy. It will not lose matter within the frame time of the experimentation. So these are the what? These are the examples, okay, of a wall. Then we'll go to what? We'll go to system. Okay, types of system. System. The types of system is defined by the types of wall that we have. The types of system is defined by the types of wall that we have. Number 1, we have an open system. An open system is a system that is having permeable wall. What does it mean? That open system allow the exchange of both energy, okay, and matter. Then number 2 is a closed system. Closed system, okay, allows the exchange of energy but not matter. It is covered by impermeable wall. What does it mean? It is a system that allows the exchange of energy but not exchange of matter. Then number 3, we have what? Adiabatic system. Adiabatic system, okay, is a system that will not allow the exchange of either energy or what? Or heat. It will not allow the exchange of either energy or heat. We call it what? Isolated system. Isolated system will not allow, okay, the exchange of both energy and matter. It is covered by adiabatic wall. Remember, adiabatic wall will not allow either energy or heat, okay, to move or to pass through. So that is number 4 or 3. Okay, that is number 1, 2, 3. Okay, number 5. All right. So please, if you have enjoyed this class till now, help me subscribe. Just hit the subscribe button as we continue the class. Okay, number 6, thermodynamic what? Terms is Okay, types of thermodynamic properties. Thermodynamic properties can be divided into two. We have extensive properties. What are extensive properties? Extensive properties are those properties that their quantity, okay, depends on the total amount of the substance of that system. It depends on amount. Their quantity depends on amount. Okay, the mass of sand depends on the quantity of sand. The volume of water depends on what? The quantity of water. So that is why, since their value is depending on their quantity, we say that they are extensive properties. So mass, volume, okay, number of moles, okay, you have free energy, okay, you have entropy, you have heat, that is enthalpy, then heat capacity. All these ones, their value depends on the amount. The more the quantity, the more the value. The more the volume of water, the more the quantity of water you gather, the more the volume of water. So they are what? Mass, volume, number of moles, okay, free energy, entropy, enthalpy, and heat capacity. Then number B is the intensive properties. Intensive properties does not depend on the total amount of the substance of the system. Let me see, for example, surface tension of water is a constant. Does not depend on whether you use water in a bucket or water in a drum. The surface tension of water is constant. It does not depend on the quantity or the amount of the water. Then we have a viscosity. Okay, viscosity. We have a density. Okay, yes. Then specific heat capacity. Okay, you have a melting point, boiling point, freezing point. All these are what? Intensive properties, because their value is independent of the amount of the substance you are measuring. Then another, this we look at, number 7, is a part function. Part function. What is part function? Part function are those functions that their value depends on the part taken. Example is a heat and work. Heat and work, their value depends on what? The part that is taken. Okay, there is a part that you take, you have what? Low heat and low work done. Okay, that is it. Then number 8 is what? State function. State functions are those functions, okay, that does not depend on the part that is taken. All right, it doesn't depend on the part that is taken. I have examples. Okay, examples here. We have a P, V. Okay, pressure. You have what? Volume here. You have enthalpy. Okay, you have entropy. So all these are part function. Now, part functions, their value can be obtained by exact differential of the final amount and the initial amount. That is to say that what? Change in pressure must be final pressure minus what? Initial pressure. They are obtained by what? Exact differentials. But the part functions cannot be obtained by exact what? Differential. Please, if you have enjoyed this class, okay, help me to subscribe, share the class. Please do follow me up in my other classes, okay, because as we go on, we are going to be making use of these terminologies. And after these classes that I'll have with you, I'm sure that thermodynamics will not be a problem to you again. Thank you.